to another week of DearPiggy's Java data structure tutorials. In this video, we are going to be introducing a new, different type of data structure, and it is our Streams API. So, Streams API is, in my opinion, one of the most important and one of the easiest to use, most awesome things that we've learned in our class so far. And I'm really excited to be talking about this because, one, it's not that hard to understand. Two, it's super powerful. So let's jump right in. The plan for today's videos is to talk about basic streams, what they are, why they are useful, create a couple of basic streams and get used to their functions. And then in our next video, we'll get into a little bit of the more complicated streams, which still isn't that complicated, but just a little bit harder than what we're going to do in this video. So let's talk about what streams are. So streams, the definition off of Google, is a sequence of data elements from a source. Now that, in my opinion, makes it sound really underrated. So basically, let's read this paragraph here and then let's figure out what it means. So we know, right, as of now, that data types all have their own functions and they vary for each one. So when we learned about linked lists, when we learned about array lists, queues, priority queues, binary trees, I can't even remember. We've learned about a lot. All of them have their own functions, right? Every single time we have like tree set methods part 1, part 2, linked list methods part 1, part 2. And all of them change depending on what data source you're using, right? But with streams, we can pass in a data source. So you would pass in like an array, a queue, a tree set, whatever. And then you manipulate them using the same set of operations. So you may be thinking, well, why are we going back into operations? Well, yes, you do have to memorize a new set of operations, but with streams, you pass in anything you want, and then you can use the same functions for all of them. So basically, we could pass in array lists, tree set, queues, priority queues, and then use the same functions for all of them by using streams. So, right, you don't have to remember all of those complicated functions anymore. You just pass them into your streams and then remember your stream functions, right? So, my opinion, and it's a rich and powerful set of operations and much easier than remembering multiple different sets of operations for different data sources. So again, you might have heard me say that Java streams are an API, which we haven't worked with, but they are an API, and I forgot what API stands for. Let me see. API stands for, I probably searched this up before, Application Programming Interface. So yes, so the streams are application programming interfaces, and basically, to put it simply, APIs are another data structure, but specifically focused on operations. So yeah, we talked about streams. One last thing that I want to talk about is this diagram here. I think this diagram really maps out the general feeling, the general idea of a stream. So we start off with a stream source, right? Our stream, as you know, is going to do operations. It's going to do something to something, right? And our something needs to be able to collect data from our stream source. And so our stream source, again, I've mentioned this multiple times, it can be anything. You can go crazy as wild as you want. You can put in your own values, save your values to an array, save your values to any data source, and then just pass it in your stream source. Then you have your intermediate operations. These are just operations that just essentially change up what's going on in your stream, right? These could be like map, filter, peek, anything like that. We'll get to more of what those intermediate operations are in a second, but just for now, remember, it's the middle operations. And then we have a terminal operation. So this is something that I want us to be careful of. Our stream, in a second, when we see, is going to look different from other things that we've done. It's going to look slightly weird because we don't have semicolons after everything. In fact, to end our stream, we use a terminal operation. And after our terminal operation, we put a semicolon. Now, our terminal operations, you can't just end your stream with any random operations. Like, you cannot end your stream with an intermediate operation. You have to use a terminal operation. And it'll be more clear in the future what these terminal operations are, but a few that I like to use and we will be using are like for each, And then collect, count, reduce, we won't be using those right now, but sum is another one, right? So you always end with a terminal operation. And you might be thinking, oh, I can't remember all these terminal operations. Most of the times it'll come naturally. So when you want to print some values out, that itself, that function would be a terminal operation. Okay, I think we've talked about a lot in streams, and hopefully it made a little bit of sense. At least I hope you can see why it's so important. I'm a little passionate about it, as you can probably tell. So the next thing that I want to do is I want to go ahead and create a basic stream, and we're going to create a basic int stream. So just looking at this picture of this example here, we can already tell that this looks different than what we've used previously, right? This looks a little bit, just a little bit like Python in its block, right? Does everybody see how after int stream, we don't have any semicolons until the end. And then the functions just start on their own. And again, no semicolon after this. Basically, the int stream, everything inside of the indented block part over here would be in the int stream. And once you're done with your int stream, you can come out of your indented block there and then start typing again. So without further ado, let me go ahead and do some examples. So let me go to Replit and then create a new REPL. Oh yeah, since it's almost Halloween, I changed my REPL, like I guess, theme to Halloween theme. Hopefully you like it. I'm a big fan. The orange, I'm not always a huge fan of orange, but the orange looks pretty cool right now. So one thing that I did forget to mention just now is it's really important that we import java.util.stream.star. Not Steam, stream.star. We used to import java.util.star. Well, now we have to import java.util.stream.star, so it's pretty important to remember that. Later in the next video, when we start working with arrays, we'd have to again import java.util.star. But just an FYI. Notice we are using two functions in this first one, and I'm going to point out to you, for each is our terminal function. That is the ending function. As you can see, there's a semicolon after it. Range is an example of one of those intermediate operations. So I'm going to type this out, and then we want to see what you guys observe happen. So int stream, and then I don't do anything. I know this is hard, especially for those of us who are used to Java, but we don't type anything, no endings. We're going to say dot range, and then give it two numbers. All right, so when we're typing this, notice how Replit says int start inclusive, int end exclusive. So this is going to be important. Keep that in mind when we see the numbers that get printed out later on, and I want you to observe what happens. So I'm just going to go from here to here, and then I don't put a semicolon. Then I'm going to say dot for each. Now this is my terminal function, and I'm going to say system.out : print. Oh my goodness, that looks so confusing, doesn't it? Well, that's again just one of the other things that stream is a little bit different with. You don't not do system.out.println, you do system.out : print. I'm going to print this out. I'm going to make some changes to it as well because this is going to bother me. And you're going to see in a second, well, hopefully this will run. There we go. All of the numbers 7 through 12 got printed out with no spaces in between. Now, since that bothers me, I'm going to say print ln, and then hopefully we'll get them all on a separate row this time. So after I run my code, you're going to see 7, 8, 9, 10, 11, 12. Now, like I wanted you to observe, notice that this number 13, we told it to end at 13. It actually ends at 12 because this last number is exclusive. So if we really wanted to print out 13 here, we would have had to gone from 17 to 14. Just a quick side note there. But now at least we can tell exactly what the range function does, right? The range function, all it does is, so if you have range x, comma, y, which are the two numbers, or that should make sense, prints out all numbers from x to y minus 1. Reason being y minus 1 is because 13 doesn't actually get printed out, 12 gets printed out. So x to y minus 1. Easy peasy, self-explanatory. For each is just simply saying, for every number that there is in my range, print it out. That's like one of our terminating operations that prints things out. So I think we're good on that. One more quick example before we end this video and move on to the next one. Basic int streams part 2. Now this, I just want to add another function to our stream and then change the way we print things out a little bit. So the first thing I'm going to do is I'm going to use our skip function. So I want you to pause the video, take a guess. What do you think skip is going to do? So if I said skip 2, a lot of you guys might think this will skip the second index or the second number, but that's actually not the case. So right now we have 7, 8, 9, 10, 11, 12. After I run my code this time, it's going to say, what is it going to say? It's going to say 9, 10, 11, 12. So what happened? Well, 7 and 8 both got skipped, right? So the first 2 got skipped. If I change this to 5, run your code again. What do you think might happen here? If I said skip 5, 12, reason being 7, 8, 9, 10, 11, all 5 of those first 5 numbers get deleted. So basically, I'm going to change this back to 2 because I don't just like having one number. The skip n function skips the, can't spell today, skips the first n numbers of, well, I'm not going to say of, just skips the first n numbers. So whatever number you have in here, it'll get skipped. So that one is also easy peasy lemon squeezy, right? One last thing that I want to show you guys is this lambda function over here. You may have noticed that I changed it up a little bit. Instead of doing system.out : print, I did x arrow system.out.println x. And this by itself is a lambda function. We haven't gotten in depth as to what lambda functions are, very possibly going to be a future video. But for now, I don't want to go too much into it. Just know that this is a lambda function and it's going to, again, print out all the numbers one by one. Some people get confused on how to do the arrow. All it is you do a dash and then the angle bracket, and that's going to give you your arrow. So I can give it, this example here used x. I don't have to use x. I can use a if I wanted to. I just have to make sure this x and this x match up. So I can say a arrow system.out.println a. So if you prefer to use println more, then this is probably for you. So now if I run my code, then we're going to see that everything from 7 to 13, excluding 13, and when we skip our first 2 numbers, is going to get printed out one by one again, right? So this doesn't change much. I just introduced to you very briefly the lambda function, right? This is a lambda function. Okay, so guys, that was that. We talked about what a stream was, the process throughout a stream, why they're so powerful, because we can do so much with them, guys. I cannot stress this more. You'll see in a second why they could be pretty cool when we start working with some more complicated stream sources. We made a basic int stream and added a function to it. I'll see you guys in the next video for some streams with some string values as well as some arrays and int arrays. So I will see you guys then. Bye, guys.